different types of forces. You can see here, these are the forces: tension force, compression force, bending or flexural force, shear force, torsion force, and this is the combined force. Tension force is defined as object or material pulled by forces acting from opposite sides. You can see in this picture, two forces are acting in opposite direction. So this is called tension force. In our day-to-day life, we can see here, this is the tension force. Here in this rubber band, tension force is acting when he pulls outside the rubber. Okay. Then how do you calculate tension force? Let's see this mechanism. A mass M suspended by spring, a force acting upward is the tension force. The downward force is the weight of mass into gravitational force. So, net force acting on this system is equal to the tension force minus downward force. That means upward force minus downward force. Therefore, T is equal to mg plus ma, where m is the mass of object, g is the acceleration due to gravity, and a is the acceleration. T is the tension force. Let's see an example. There is a 10 kg mass hanging from a rope. What is the tension in the rope if the acceleration of the mass is 0? That means A is 0, M is 10 kg. So, we know that the force of tension is calculated using the formula T is equal to mg plus ma. Substituting the values in the equation, we get T is equal to 10 kg into 9.8 meter per second square, that is acceleration due to gravity, plus 10 kg, that is mass, into acceleration due to gravity 0 as mentioned in given problem. So after the calculating tension, T is equal to 108 newtons. So let's see, now assume that there is an acceleration 5 meter per second square upwards. So why here indicated plus sign upward. So plus 5 meter per second square, that means upward in direction. Okay, substituting, we get tension T is equal to 10 kg into 9.8 meter per second square plus 10 kg into 5 meter per second square. After calculating, we get tension T is equal to 148 Newton. Similarly, assume a downward acceleration of A, that's equal to minus 5 meter per second square. Substituting, we get T is equal to 48 Newton. I hope this problem is clear to you. Second one is compressive force. Compressive force occurs when a physical force presses inwards on an object, causing it to become compacted. You can see in this picture, when two forces are pressing the object inward, so here compressive force is acting. In civil engineering works, we can observe this. This is a compacted soil, and that a concrete platform, and that bricks are placed. These bricks are loading downward, and this compacted soil is reacted upward. So this concrete platform is under compressive force. In elastic material, when compressive forces occurs, that material will expands after releasing the compressive force, that will become its original position within the elastic limits. But in the rigid material, when we compress that, after the yielding stress, that will break. So you can observe here. Next one is flexural force. Flexural force is a ability of the material to withstand bending forces applied perpendicular to its longitudinal axis. So let's see, assume this is a beam and a force acting on it. Now we can observe here, due to this vertical load, this beam bends like this. So this is the bending force or a flexural force. Next one is shear force. These are unaligned forces pushing one part of a body in one specific direction and another part of the body in the opposite direction. As I said, you can observe here, one force is pushing a body in one direction and another force is pushing a body another direction. This is a shear force. Okay. Single shear and double shear. We can observe here, two plates are there, both are pushing in opposite directions. So here creates a shear force. In this, there are three plates, two plates in one direction and middle plate is other direction. This is called double shear. If you twist a material in a opposite direction, there will create a torsional force. You can observe that mechanism in this figure. This also you observed in your day-to-day life. This is an example for torsional force. Punching force. If any object suddenly drops on any platforms, there creates a punching force. So you can see in this figure, this acts as a punching force and these two are a holding force. Thank you.